Now we'll watch the application of perimeter finishing elements. In this case, the drilled metal sections are hammered in with special pins to fasten the ends of the membrane around the perimeter of the wall. The next thing to see is the creation of an extremely important detail. Here in my hand I'm holding a cord in TPO, the same material used for the synthetic membrane we've just laid. This cord will be sealed in the upper part of the metal section we've just laid using this instrument, a hot air blower. This fundamental element is available in TPO for use with TPO membranes or PVC whenever necessary, in order to ensure uniform tightness throughout the entire surface of the drilled metal section perimeter, and not only at the fastening points. Now we'll proceed to the application of the second layer. As you can see, the first layer has a line on top that indicates how far the overlap should extend. And this is very important for the successful laying of the product. In order to ensure the perfect sealing of synthetic membranes, the laying surface sealing area must be previously cleaned and prepared perfectly. Our installer is using a special cleaning preparation liquid to remove all traces of dirt that might compromise sealing. The equipment required for sealing includes industrial hot air blowers that are special because they must work at determined temperatures. The larger device is an automatic sealing device that must be positioned to run along longitudinal sections. The smaller hot air blower is used by hand for details and finishing elements. As you can see, the installer uses the metal pressing roller immediately after heating up the polyolefin membrane's underside. Sealing occurs in two precise moments in order to ensure the perfect melting of the two layers. The part above the drilled metal section is now being cut away in preparation for the application of the connecting strip that will be glued and connect the system's horizontal and vertical parts. The creation of the inside corner is very important. You can see that it's cut exactly on the inside corner prior to subsequent sealing with hot air. Now we are preparing the connecting strip to be positioned between the system's horizontal and vertical parts. As you can see, it's folded over. The black part will be positioned on the horizontal part, and the white part that can't be seen will be positioned on the vertical part. Now we see them marking the vertical turn-up's highest point and drawing a reference line. The next step will be the laying of a special glue that hardens shortly after contact, MAPEPLAN ADS 300. Our installer is now laying this very fluid product that has no particular precautions. The glue must obviously be applied to both contact surfaces and given time for the solvent to evaporate in order for ideal adhesion to take place. As you can see, the connecting strip has been coated with glue only on its vertical or upper side. In other words, the part that will come into contact and adhesion with the reinforced concrete. The part of the strip that will come into contact with the horizontal surface remains free from glue because it will be sealed by the hot air blowers we've seen above. It is therefore very important to avoid applying glue where the membrane will be sealed horizontally. Now we can see them applying the definitive turn-up. The glue's excessive solvent has evaporated by now, and the glue can harden immediately. The horizontal undersurface will be subsequently sealed by hot air. A metal plate is inserted for starting, and then the machine automatically seals up to around 30 or 40 centimeters from the corner. This last distance will obviously be sealed manually. The creation of an inside corner is always interesting to watch. The installer makes a cut that will permit the membrane to be subsequently folded over on itself. It's always important to make sure that the area is perfectly clean and free of dirt that might compromise sealing and adhesion. The hot air blower and roller are then used to promote sealing near the corner. The final part of the process features the use of one of the many accessories available with MAPEPLAN synthetic membranes. In this case, a prefabricated inside corner made in TPO polyolefin membrane and therefore perfectly compatible with the membrane used. The same hot air blower is used for its application. Here we are at the end of the layering. The upper metal finishing element has been positioned and is now being glued in place with a special silicone adhesive. Here we see the application of another important detail, an outside corner. Here as well, a prefabricated element will be used, another member of the complete range of accessories for synthetic membranes. As usual, the membrane must first be cleaned of all traces of dirt and prepared using special MAPEPLAN T cleaner liquid. Our installer will then apply the element with a hot air blower. This simple operation is fundamental in ensuring the success of the waterproofing system. It's also very important to carefully check the temperature of the hot air blower, because temperatures that are too high or too low will fail to create the molecular bond necessary for the sealing of the membranes. Now our installer is using another tool. Instead of the metal pressing roller seen previously, he has a smaller pressing wheel that's more suitable to applying the correct pressure at 90-degree angles. With its range of MAPEPLAN synthetic membrane products, Polyglass can now offer a complete assortment of special pieces and the tools required for their application. Here we'll be watching the execution of another very important detail that's widely used in roofing, the pass-through pipe that can serve as a vent pipe or a flue stack. Our installer has taken the exact measurements and cut a section of polyolefin membrane that he will use to make a tube of his own as the basis for the waterproofing to be provided for this ventilation system. A corner of the membrane section is cut away in order to provide a larger contact surface at the bottom. The tube is sealed for its entire length and will then be slid over the pass-through pipe. The installer is now heating up the lower inside of the tube that he has made in order to make it more malleable and permit the flaring of the diameter at the bottom that will permit its sealing to the horizontal surface. Another distinctive feature of polyolefin membranes, or synthetic membranes in general, is their capacity to be slightly heated up for improved malleability that permits easier modeling by hand. Here, this type of collar made by our installer is very easy to see. Now he's using the smaller pressing wheel we saw above that permits the correct application of pressure. As you can see, the aesthetic result is excellent. The heated product doesn't soil the surface or create smoke.